All right, this is our lesson on finding inverses or inverse functions. And we have an objective for today, which is I can identify if functions are inverses and apply inverse properties of functions. So let's get started with what is a function. So it says let f be any function or any set, or an example, a set of ordered pairs, for example. We can create another set of ordered pairs by reversing the pairs in x, so switching x and y. Call this new function f inverse, and how you write f inverse is like this. This is how you write f inverse, and this is how you say it, f inverse. So in other words, if AB is on the graph of a function, then BA is on the graph of its inverse. So all you have to do is switch x and y. That's what an inverse is. Okay, so this says, find the inverse of the following functions based on the above definition. So we are going to find the inverse of this function, and then we also want to know, is the new function, is the inverse a function itself, okay? All right, so switch x and y for this. So here's our bracket to bring it all together, and then our ordered pairs would be 1, 0, 3, 1, -5, 2, and 7, 3. So that's the inverse. And now the next question is the inverse a function? So look at every x value and make sure that it only gives an output of, it gives only exactly one output. And if you look, that's true for this. So yes, this is a function. All right, looking at the next one here, we're gonna switch x and y for all of our ordered pairs here. So 0, 0, 1, 1, 1, -1, 4, 2, and 4, -2. And it has ... after it too, don't forget that. All right, so is this a function? No, this one has an output of 1. Or sorry, this one has an output of 1, but this one has an output of -1 also, so this is a no. All right, 3a here, let's go ahead and find the inverse, switch x and y. So we have 5, 0, -5, 1, 6, 2, and -6, 3. All right, so this one is a function. F inverse is a function. If you look, every input has exactly one output. I also want the domain of f, okay? So the domain of f, remember when we were writing domain, we were writing it from smallest x value to biggest x value with no repeats. So 0, 1, 2, 3. And then we're gonna write the range of f also. So that is your y values doing the same thing. So we're gonna do -6, -5, 5, 6. So there's your range. Now we're gonna do the domain of f inverse, which is -6, -5, 5, 6. And the range of f inverse is this. Okay, so if you look, the x and the y value switch for this. This should not be anything crazy here. It's by definition, right? What relationships do you observe between the domain and the range of f and f inverse? That's what we just said, right? The domain for f is the range for f inverse, and the range for f is the domain for f inverse. All right, so how do we find an inverse algebraically? So like when you have an equation like g of x right there, all right? So how do we find that the inverse of that if it's not a list of ordered pairs? So there are some steps that we can write down. The first step is exactly what we did with the ordered pairs. Well, actually, no. If this is g of x, we want to rewrite it as y. I tend to not skip the step, but just like imagine it first. So rewrite as y equals instead of g of x equals. Okay, so the second step is exactly what we were doing above, which is that you switch x and y. After you switch x and y, you're going to solve the equation for the new y. I'll put new in quotes here. All right, like the new y, the y that we just designated as the new y, and then rewrite as inverse. So rewrite as inverse, or in like inverse notation, okay? All right, so it says, using the above definition of an inverse, find the inverse of the following functions. So in class, we'll do this one together, and then you'll try this on the person next to you, and then you're going to try this one on your own, but I'll do all three of them really quickly. So first off, you're going to rewrite it as y equals instead of g of x equals. This is the step that I tend to skip. Like, I just automatically switch x and y. Like, I can imagine this being a y. I don't have to rewrite it. All right, now you're going to switch x and y. So you have x equals 5 minus 2x all over 2. And now you are going to, sorry, this is supposed to say y right here. I have to switch x and y, and I wrote it as an x again. And now you're going to solve for y, so get y by itself. So to get y by itself, I'm going to multiply both sides by 2. So I have 2x is equal to 5 minus 2y. I'm going to subtract 5 from both sides. So I have 2x minus 5 is equal to negative 2y. And then I'm going to divide both sides by negative 2. So we have y equals, so I got my y equals by itself now, but I'm going to write my answer in function notation. So instead of writing y equals, I'm going to write g inverse of x equals 2x minus 5 over, and then remember, we do not like negatives in our denominator, so I'm going to put it in front, negative 2. Okay? So there is your inverse. Now, if you want to divide both of those terms by 2, you could. You could have g inverse of x is equal to, if I divide this by negative 2, or sorry, divide that by 2, or negative 2, I should say. Divide that by negative 2, I have negative x. And if I divide negative 5 halves by negative 2, I have positive 5 halves. So either one's fine, but I would just leave the first one. It's less work, right? All right, this one here, so rewrite as y equals and then switch x and y. So I have x equals square root of 2y minus 3. And then to get rid of that square root, we're going to square both sides. That's x squared equals 2y minus 3. Add 3 to both sides. X squared plus 3 equals 2y. And then divide both sides by 2. So we have y equals x squared plus 3 over 2. Once again, you can divide both by 2 and say you have 1/2 x squared plus 3 halves, but I don't think that's necessary. But it is necessary to write it as h inverse is equal to x squared plus 3 all over 2. And there's your function. All right, moving on to the last one here. You can go ahead and pause the video and try this one yourself and see how you did. Y equals 2x plus 3, switch x and y. X equals 2y plus 9. Subtract 9 from both sides, divide by 2. So we have f inverse of x is equal to x minus 9 all over 2, or 1/2 x minus 9 halves. Okay. Next part right here, graphs of inverses. It says use your graphing calculator, but I changed your notes already because we already know how to graph these. So it's just graph. Let's do that. Graph the following function. So we have f of x equals x cubed. So we know what x cubed looks like. 0, 0, 1, 1, 2, 8. Negative 1, negative 1, negative 2, negative 8. And then we can go ahead and make the cube root function. Okay, so there's our cube root function. And so there we go. Now it's going through those points that I made. Okay, and then it says solve for the inverse of x cubed. So we're going to switch x and y. So y equals x cubed. Switch x and y. You have x equals y cubed. And then solve this for y. So you have two ways of getting y by itself. You can cube root or bring to the 1/3 power. So you could have x to the 1/3 equals y, or you can have the cube root of x equals y, which is what I prefer personally. So we have f inverse of x is equal to the cube root of x. Okay. All right, so now it says graph that on the same graph, which we know how to graph the cube root also. It actually has these same 3 points, right? But it has 8, 2 on it instead of 2, 8. And then same idea here, but it has -2, -h. Okay. All right, so that's the inverse. Now, if you look at these two graphs, you should notice that they are reflections of each other. It's not a reflection over the x-axis or a reflection over the y-axis, but it's a reflection over a vertical line, not vertical line, a slanted line with a slope of 1 and a y-intercept of 0. Let me change this to a dashed line because otherwise it's adding to the, it's saying that it's part of the graph, which it's not, okay? All right, so that's the line that it's reflecting over. That line, once again, has a slope of 1 and a y-intercept of 0, so it's the line y equals x. This is true about all inverses. Two functions are inverses if they are reflections of each other over the line y equals x. And you can get that by switching the x values and the y values. I notice they have these 3 points in common because if I switch 1, 1, I get 1, 1. If I switch 0, 0, I get 0, 0, so on and so forth, right? Okay, so let's go ahead and look at this one. We're going to use the same procedure. We're going to graph y equals, or f of x equals x squared plus 4. So that's a parabola shifted up 4. Okay, so this is what it looks like. We know that already. We know how to graph. Okay, so there's my parabola. Now it says find the inverse right there. So we're going to switch x and y. So we'll do x equals y squared plus 4. Subtract 4 from both sides. X minus 4 equals y squared. And then square it to solve. Don't forget to account for both the positive and negative. So we have f inverse equals plus or minus the square root of x minus 4. All right, so you know how to graph the square root of x minus 4. It's the square root function shifted right 4, right? So we know it's right here, okay? But if you're like, where are my other points? You can plug in 5 and see that you get 1, but you also get -1. Because you plug in 5, you get plus or minus 1. So you have a piece down here too, right? And then I wouldn't plug in 6, wouldn't plug in 7, I would plug in 8. Because when you plug in 8, you get the square root of 4, which is 2, and then you also get -2 from the plus or minus part. So here and here. So you have this parabola that opens to the right, okay? Now if I copy and paste this, I'm gonna do that. Copy, I said, come over here, paste. If you look, come on, come with me, thank you. At that line y equals x here, okay? You can see that this is also a reflection. Oh, I graphed mine wrong, so that's not helpful. I graphed it at 0, 2. That's pretty. So let's move it up to where it's supposed to be. 0, 4. There you go. Up 4, not up 2. There we go. Now it's a reflection over the line y equals x, right? You can see that there's a mirror image of each point. So also please notice that this is the point 4, 1, or sorry, 1, 5. And then this is the point 5, 1, right? This is the point 4, 0, and this is the point 0, 4. So all the x values and y values are switched, and the result gets a reflection over the line y equals x. Next it says write a sentence or two describing the graphical relationship between the graphs of f and f inverse. So all graphs f and f inverse will be a reflection over the line y equals x. Here it says look back at the opening exploration to determine which cases f inverse was a function. How about looking at the graph of the function? Can you determine whether or not f inverse is a function? So look back at the opening exploration. Let's come back over here. Is this the opening exploration? Yes. And what did it say to do? Sorry. Look back at the opening exploration and determine which case, that f inverse was a function. Now by looking back at the graph of the function, can you determine whether or not f inverse is a function? Okay, so this was, I see what it's saying. So we said no, that the inverse is not a function. We said yes, the inverse is a function. So it's asking us how could we have looked here to see that the inverse was not a function. So we can just look backwards, right? We can look at the y values and see if they give us exactly one x value. And if we look here, this y value gives us two different x values. So we can say the inverse is not a function. Going back to the ones with the graphs, if we look at this, we can do the same thing here, right? We can look at the y values and see that the y values do give us the same output, right? This is the ordered pair -1, 5, right? So y gives us an output of 1, y gives us an output of -1. So here, we know that the inverse would not be a function. Like it itself, the pink one is a function, right? It passes the vertical line test, okay? But the blue one doesn't pass the vertical line test. And once again, we can tell by looking at this function right here, by looking at the y values and seeing they have repeated x values. Another way of thinking about it is that you can do a horizontal line test. If we do a horizontal line test, which is the same thing, if we do a horizontal line test, it doesn't pass it. Therefore, this would not pass a vertical line test. Yeah? Okay, so what is this called? This function, okay, this function and its inverse are both functions. So the blue one is a function, passes the vertical line test. The red one is a function, passes the vertical line test. So this is called 1-to-1. On this one, this is a function, this is not a function, okay? Or I can check it here, vertical lines, this is a function, its inverse is not a function. So therefore, it's not 1-to-1. A function is said to be 1-to-1 if it passes the vertical line test and the horizontal line test, okay? But also this means that every element in the range is paired up with exactly one element in the domain. So like that 5-to-1 and 5 to -1, not okay, not 1-to-1. Here it says, let's consider the compositions of f inverse of x and f inverse of f of x. So it says, given this function, find its inverse. So let's go ahead and switch the x and y values. 5, 0, -5, 1, 6, 2. Man, everything's kind of big for this. I'm going to zoom in to make it easier. And -6, 3. -6, 3. Okay. All right. Given those two functions, we're given that function, find the inverse, got that, and then find the following. So f of 2. So that's go to the function f, right? And when the x value is 2, what's the y value? So I'm going to go to the function f. I'm going to look for the x value of 2 right here, and it's asking you what the y value is, 6. Okay. All right, let's do the one to the right of that. So now it says find f inverse of f of 2. So remember, f of 2 we just got is 6. So find f inverse of 6. So what that means is go to the function f inverse. All right, go to the function f inverse. And it's saying when x is 6, what is y? So here's 6, that's 2. See that? All right, so f of 0 is 5. So this is 5. F inverse of 5 is 0. F of 3 is -6. F inverse of -6 is 3, right? So their x and y values are switched, that's true. Takeaway from this, if f inverse is a function, then f of f inverse simplifies to x, and f inverse of f of x also simplifies to x. If you're like, how is that my takeaway? It's what it's saying is that this will simplify to whatever this was right here. This will simplify to whatever this was right here. I'll just simplify to that x value. Okay, so now what we're going to do, the last thing we're going to do, is we are going to show, we're going to use this, or this, we're going to show that two functions are inverses of each other. What people try to do is take one and simplify it, and find that inverse and show that you get that. We're not going to allow that, okay? So to show that two functions, when it says verify the functions are inverses of each other, you're going to need to show that f of g of x simplifies to x, and g of f of x also simplifies to x. All right, so let's go ahead and do problem A right here. So we have f of g of x. We're going to find that and show that it simplifies to x, okay? And then we're going to do g of f of x. So that means take the function g, which is this, and plug it into f right here. So we have 2. Instead of writing x, I'm going to write the cube root of x plus 1 over 2. And then this minus 1 right here. Oops, I forgot this cube also. Cubed minus 1. Okay, so now I have to show my steps of simplifying this. You can't do it all in one step because I won't be able to tell what you did first, second, third, so on and so forth. So I know that first I can say that this cube is going to cancel out this cube root, right? Then the 2's, then the 1 and the negative 1. But I have to show that in steps. So now I have 2 times x plus 1 over 2 minus 1. 2 divided by 2 is 1, so these 2's now simplify to 1. I have x plus 1 minus 1, and the plus 1 and the minus 1 cancel out, and you're just left with x. So there's that. Now I have to do f of g of x to show you that you also simplify to x. You can't just do one, you have to do both. G of f of x is, so now we're going to take f and plug it into g. So we're going to take, let me erase my markings here. I'm going to take this and plug it in right there. Right there. All right, so we have cube root of, instead of writing x, I'm going to write 2x cubed minus 1. And we have plus 1 all over 2. We got to clean this up, okay? So here, the first thing we can simplify is the negative 1 plus 1. So now we have the cube root of 2x cubed over 2. I can simplify 2 divided by 2, right? That's 1. Now I have the cube root of x cubed, which the cube root and cube cancel out, and you're just left with x. So there, you just verify that they are inverses of each other by showing that f of g of x simplifies to x and g of f of x simplifies to x. So yes, it needs to be done in the same amount of steps that I did. Okay, last one, find f of g of x, verify that they're inverses of each other. All right, so we're going to take g of x and plug it into f. So I have 5 over, instead of writing x, I'm going to write 5 over x plus 2, and then you have minus 2. All right, clean it up. The plus 2 and minus 2 cancel out first. Now you have 5 over x. So instead of writing it like that, this is divided by. So I know that instead of dividing by a fraction, I'm going to multiply by the reciprocal instead. So instead of writing it 5 divided by 5 over x, I'm going to do 5 times x over 5. And then 5 and 5 cancel, and I'm left with x. All right, lastly, g of f of x. So take f of x and plug it into g. So I have 5 over, instead of writing this x right here, I'm going to write 5 over x minus 2. And then we have this plus 2. All right, we need to clean this up. So first thing I'm going to do is I'm going to do multiply by the reciprocal with this because it's ugly. It's a complex fraction. I do not like it. So I'm going to do 5 times x minus 2 over 5, and then it's plus 2. All right, so I can simplify the 5 divided by 5 first. I cannot simplify the x minus 2 plus 2 first. So minus 2 and then plus 2. And then now I can simplify this. That's equal to x. All right, so I showed f of g of x is equal to g of f of x, which is equal to x. All right, that's it for today. You can